to the second salt problem. This one is analytium chloride, which on this problem we're not given a concentration, we're given a pH, and we're going to look for the concentration. The other thing about this salt is when it dissociates into analytium, which is positive plus Cl minus. So this is the conjugate acid of a weak base. Again, the chlorine is neutral, has no effect on pH because it's the conjugate of a strong acid. So again, we're going to ignore that one, but this is the conjugate acid of a weak base. Now, there are a couple ways again to look at this one, but what we're going to do is set up our equation first. So we're going to start with C6H5NH2 plus. This is a weak acid, so we're going to dissociate the acid off of it and be left with our neutral species, which is C6H5NH. Now, this is a weak base, so it has a Kb value. So if we look up the Kb value, we get 4.0 times 10 to the minus 10th. Again, we don't need a B value, we need a Ka value because we're producing a proton, hydronium ion. Okay? So if we go over here, remember the Ka is what we need, so Ka is equal to Kw divided by Kb. And remember, Kw is 10 to the minus 14th. So when we do our math, our Ka comes out equal to 2.5 times 10 to the minus 5th. Now, let's go over here and do our ICE table. Well, initially, we don't know. We're looking for the concentration, so if we don't know, we call it X. Initially, we have 0, 0 here. We're going to lose an amount. I'm going to use delta. We're going to gain it here, gain it here. So at equilibrium, we have X minus delta, delta, and delta. Now, wait a minute. We've got two unknowns, and we only have one equation, so we only need one unknown. So let's go look at what we have and see if we have additional information. And yes, we do. We know that our pH is equal to 3.02. That means my hydronium ion concentration is equal to 10 to the negative pH, which means that the hydronium ion concentration is going to come out equal to 9.5499. So we're going to call this 50 times 10 to the minus 4th. Now, if we look at this, we can say, oh, well, this is 9.550 times 10 to the negative 4th, and this is 2. So this value comes out equal to X minus 9.550 times 10 to the minus 4th. So now let's just do our Ka, and remember it's Ka because we're dealing with an acid. So it's going to be 9.550 times 10 to the minus 4th squared divided by X minus 9.550 times 10 to the minus 4th is equal to, remember our Ka is over here, 2.5 times 10 to the minus 5th. Now, there are a couple ways to work the math from here. You just follow the rules. There are a couple ways to do it. I'll tend to work it one way and everybody else tends to work it another way. Basically, you square this value and you multiply this by this and distribute it out. you end up with x equal to 0.037435. That means that if we're using 4 non-zero digits, your salt concentration is equal to 0.03744 molar. So this is how we calculate the salt. Now, one other statement is we did not have an x squared term, so no quadratic. Everybody tries to run this through the quadratic, but just remember, if you don't have an x squared term, you cannot use the quadratic. So the math is actually a little easier for this problem. Okay?